Hello everybody, my name's Danny Poole, and in this segment we will discuss SMA Design. I know the slide says SM 4.75, but at this moment we'll probably not touch on that at all. We'll concentrate on the SMA. So SMA is defined as a gap-graded mixture simply due to the nature of a non-uniform distribution of aggregate sizes. So if you were to plot your gradation of an SMA design on a 45 power chart, it would not resemble the gradation of a super pave conventional mix. These mixes contain aggregates that are retained on the upper and lower sieves. Thus, the name gap graded refers to the gap in the middle of the sieves or the middle sieves with hardly any aggregate retained. So imagine if you plotted an SMA final design blend on a 45 power, it typically will not stay with the maximum density line that a dense graded conventional mix would. It would drop off and drop very, very sharply downward, representing the gap grade of no particles being present in the middle sieves. And that'll kind of coincide with the next description of this SMA mix, typically having 75 to 80% coarse aggregate, has a high binder content, 9.5 and 12.5 millimeter mixes on SMA have a minimum asphalt content of 6.3%, and it also has a high filler content, typically 10%. So again, with a very high coarse aggregate content, a high binder content, and a high mineral filler content, like I said, about 10%, that results in a very durable mix that has excellent stone-on-stone contact, that is very durable and rut resistant. It is that combination of the mineral filler, the high binder, and the cellulose fibers that serves as a mortar or a paste, if you will, to fill the voids in between the coarse aggregate and help maintain the aggregate structure. It fills those voids, that paste. Along with being we have a very high binder content, to help aid in drain down, the mineral filler does play a role in that. The cellulose fibers and the high mineral filler content helps aid in the binder not running off of the stone. So in Virginia, SMA is typically placed on interstates, other primaries with heavy traffic loads and or a lot of truck traffic. When designing a SMA mix as compared to conventional mixes, there are new concepts and terminologies that need to be understood. Breakpoint sieve. Breakpoint sieve differentiates the coarse aggregate portion of this blend and the fine portion. So on a 12.5 millimeter and a 19 millimeter, the breakpoint sieve would be the number 4, or the 4.75 millimeter sieve. And on the 9.5 millimeter, it would be the 8 sieve that differentiates the difference between coarse and fine aggregate. We're going to talk about the VCA and the DRC, which is the voids in the coarse aggregate in a dry rotted condition. We also talk about the voids in the coarse aggregate of your mixture during production. So just an overview of this presentation. Some of the things that's going to drive this PowerPoint slide is the evaluation of aggregate properties. We're going to develop 3 trial blends with varying amounts passing the breakpoint sieve, depending on which mix you're using, and we'll talk about the breakpoint sieve in a minute. We're going to select a blend that has the highest percent passing the 4, which meets minimum VAMA requirements, and a VCA of the mix passes during production, but It's recommended, but it doesn't always mean that's the case. That's the design you're going to go with. We're going to determine the optimum AC content and check drain down. All right, we're going to spend a few minutes and talk about aggregate properties. And there are some notable differences. For instance, the flat and elongated, the F&E. On your everyday conventional mixes, we're all used to having 10% maximum on the 5:1. On the SMA, it drops down to 5% max on the 5:1, and now a 3:1 ratio is introduced, which you cannot exceed 20%. Of course, aggregate angularity requirements are more stringent, with the 1 fractured face and the 2 fractured faces with 100% and 90% minimum. In section 248, which is a specification for SMA, I'm going to talk about a couple of things that relates to this slide, but it's not noted on this slide, is that your blend for your design must contain 2 or more coarse aggregate sizes. 2 of those coarse aggregates must comprise a minimum of 10% of the total blend. A lot of the SMA that I'm familiar with that we run, we typically have 3 coarse aggregates, and 2 of those 3 must comprise more than 10% of the blend. I like 3 coarse aggregates in SMA. It gives you more flexibility and more room to adjust during production. And that's really a big deal if one of your aggregates runs coarse or fine and you kind of run out of adjustment. So to have that 3rd coarse aggregate is a huge plus. On your fine aggregate angularity, also known as your uncompacted void content of a fine aggregate, if you are using wrap in your blend, the FAA value must not exceed 45% on your SMA design blend. Mineral filler, you are permitted to use and blend 2 mineral fillers. Typically, the SMA that I'm familiar with that we run, we use 1 mineral filler. Mineral fillers in the region where I work are kind of limited. The availability is not all that great. But if you choose to go with 1 mineral filler, or it doesn't matter if it's both, tend to use a mineral filler that has a high percent passing the 200. Now the specification states that the minimum is 55% passing the 200. And I bring that up not only because it's in the specs and it's required. We talked about the breakpoint sieve a little while ago, and if you're trying to get 9.5%, let's say, passing your 200 on your design, and if you use a mineral filler that's right at 55% passing the 200, that's going to force you to put more mineral filler into your mix, therefore running a risk of your VCA and mix of failing. Experience tells me in my case that I like to use a mineral filler anywhere between 65-73% passing the 200. And remember, the minimum is 55% passing the 200. Cellulose fibers, the minimum dosage rate is 0.3% by weight of total mixture. And if you want to run wrap in your SMA, refer to table 2-26 in section 248. Depending on what binder the contract calls for, will either be 15 or 20% maximum allowable wrap, depending on the binder. Just back to the F&E for a moment. All aggregate for each stockpile must meet the minimum or maximum criteria specified, except for F&E. So if you're using 3 coarse aggregates, the F&E at the time of design is based on the mathematical blend of those 3 coarse aggregates. So essentially, let's say if you had 1 coarse aggregate and the 3-to-1 ran a 22 and your 5-to-1 was a 5/8, And your other two coarse aggregates were substantially below that in the average based on your percent feed of your blend. That mathematical blend is where you'll gain approval on your mix design. So remember that. But during production, we also check F&E during production. And how that's done, on your first lot of production, we are to run 2 F&Es on that lot out of those 8 samples. Those samples are obtained from the ignition burn after the gradation has been performed, and you run a gradation twice on lot 1. If they run satisfactory, if they pass, then you run 2 more F&E samples afterwards every other lot. So you would run 2 more in lot 3, 2 more in lot 5, and so forth. Here's some of the new terminology that I spoke of earlier. VCA, the voids and coarse aggregate. The VCA is also a term similar to VMA. It is a measure of void space between only the coarse aggregate. So imagine, if you will, if you compacted a pill of SMA, and if you remove the binder, the mineral filler, and all the fine aggregate particles, and that pill still stayed in place, that represents the VCA. The VCA in the dry rotted condition is done at the time of design, and it's simply obtained by compacting the coarse portion above your breakpoint sieve in your coarse aggregate. The VCA mix, that's the voids in a coarse aggregate of your mixture of a compacted SMA sample. And during production, that value must be less than the VCA in the dry rotted condition at the time of design. If that value exceeds the DRC, you're going to lose your stone-on-stone contact, and according to Section 248, you are to cease production. The next few slides are going to be pictures of the equipment needed when you are determining the voids in a coarse aggregate during a dry rotted condition. So you will need your calibrated measure with a scoop, with a rod. So you have your blended coarse aggregate, whether it's 2 coarse aggregates or 3. All the material that's sieved over the breakpoint sieve, and you're going to introduce 1/3, enough aggregate to fill 1/3 of that measure. So you're going to get your rod, and you're going to rod it without hitting the bottom of that container 25 times. And you're going to repeat this step 3 times. The second layer, to do it 25 times, you don't want to penetrate the first layer. When you're leveling off the top of this measure, you don't want to use the rod or anything to apply unnecessary pressure on top of this aggregate. You want to drag the straight edge of the rod carefully over the top. And when you're looking at it from the side, you want to have the same amount of particles pointing above the surface of that container as they point downward. Just by looking at that bucket of aggregate there, represents to me a good particle shape, good F&E to make a successful SMA. This slide here explains what the voids and coarse aggregate in the dry rotted condition represents to the picture of the right of the slide. So you got 2 factors. You got your coarse aggregate and you got your air. And that is the equation. You would need your GCA, which is your gravity of your coarse aggregate, the unit weight of water, and the weight of your measure and the weight of your aggregate to come up with the value of the VCA and the DRC. That should look familiar from your SuperPave mix design class. That's just a calculation where we're getting our gravity of our coarse aggregates. That is needed in that equation. Here's a new terminology that we discussed a few minutes ago. It's the VCA in the compacted mixture. See, now we're adding a few more things to the picture to the right of the slide. Still got our coarse aggregate, we still have our air. Now we're introducing asphalt and fine aggregate. This calculation is calculated during production. You need your bulk mixed gravity from your pill. You have your gravity of your coarse aggregate that is determined during design, and your percent passing the breakpoint sieve. And that's going to determine during production your VCA of mix. You know, I was speaking earlier about mineral filler, and if you have a coarse mineral filler, the more you're going to have to introduce to your mix. If you have a coarse aggregate that goes fine, those two factors drive what that breakpoint sieve runs. And it also drives whether you're going to be successful in your VCA of mix during production. And again, Section 248 during production, if the VCA of mix exceeds the VCA in the DRC, you are to cease production. This slide here, when you determine your binder content and your gradation, it's a percent coarse aggregate that's retained on the breakpoint sieve expressed as a decimal. So a lot of this picture here, this slide here, the picture on the right, when your VCA of mix is running less than the void's coarse aggregate in a dry rotted condition, you're going to have a mix that's strictly stone on stone. Now the picture to the left on this slide is paints a picture if your VCA mix is failing. And if that is happening in a roadway, rutting is to surely happen. SMA is 75 gyrations. Most of the conventional mixes, your dense graded everyday mixes, we're dealing with 50 gyrations and 65. But on SMA, it's a 75 gyration mix, and max is not used or specified. Indications of a weak aggregate skeleton. If you're out on the roadway and you watch that roller make its first pass, you shouldn't see any indentations in the mat. It should look the same when the roller passes over it. If you do see an indentation in the mat after the roller hits it, you're probably in trouble. Failing VCA. You know, we talked about that several times. Failing VCA during the mix, during production, is certainly a weak aggregate skeleton. This concludes this presentation on SMA. If you have any questions, please direct them to your proctor that's running this class, and that's it.